Okay, welcome back to McNab A-Level Chemistry. Today we're going to have a look at redox reactions. So firstly we need to understand what a redox reaction is. So let's write that down. Okay, so a redox reaction is a reaction where oxidation and reduction take place at the same time. Really, the term redox tells us the whole story. So if we look at it, redox, or as some people call it, redox. The red bit is the reduction and the ox is the oxidation. The best way to understand this really is to first of all know what you're looking for in your equation. So let's write those down now. Okay, get rid of that. Okay, so first of all, oxidation happens when, number one, a species in an equation gains oxygen. So a species in an equation gains oxygen. Number two, a species in an equation loses hydrogen. Number three, when a species loses electrons. Or finally, number four, when there is an increase in oxidation state. So when there's an increase in oxidation state, and we're going to have a look at that in part 2. Okay, now reduction. Okay, so reduction happens when, number one, a species loses oxygen. Number two, a species gains hydrogen. Number three, a species gains electrons. Or number four, when the oxidation state of a species in an equation gets less, i.e. is reduced. Okay, so there we go. When the oxidation state of a species in an equation gets less, i.e. is reduced. Right, next job then, if we have a look at an equation and then work our way through this. Right, so the equation I'm going to choose today is quite a nice simple one really, and it's one that you've seen before from GCSE. Okay, so if I take some magnesium, react that with some diatomic oxygen, O2, they will react together and will make magnesium oxide. I need to balance it, a 2 there and a 2 there. So let's look at the different species individually. So first of all, I'm going to take the magnesium. In that equation then, the magnesium there, the type of species that is in that equation, they are magnesium atoms. So a lump of magnesium is made from lots of magnesium atoms. Okay, O2 is a diatomic molecule, so we've got a covalent bond between the two oxygen atoms in the diatomic molecule. And then the magnesium oxide, well, that's a metal and that's a non-metal, so we think back to our bonding, and when you have a metal bonded with a non-metal, we have ions. Okay, so in that compound there we've got magnesium ions, Mg2+ ions, and oxide ions, O2- ions. Okay, so first of all we really need to understand the equation and understand what chemical change is taking place. So I'm going to look at the magnesium first of all. Some of you will look at that and you'll think, well, the magnesium gained oxygen, so therefore the magnesium is oxidized. That's absolutely perfectly correct, and it's an okay way to think, but there's a little bit more to it now. We're at A level. Okay, so let's look at the magnesium to start with. So if I take my magnesium, move that this way a little bit, if I take my magnesium atoms, what have they become in that reaction? Well, they've actually become magnesium ions, Mg2+ ions. Now when I look at that equation, not only do my number of magnesiums have to balance, so I've got one there and one there, but also my charges now need to balance. So on this side of the equation, on the left hand side of the equation, there is no overall charge, so the charge is 0 on that side. On the right hand side of the equation, the charge is +2. So clearly that half equation is not balanced. So I can balance that. I need to get that +2 down to 0. So if I add 2 electrons onto this side, so plus 2 electrons which are negative, so 2 electrons which are negative, so Mg2+, that's +2, plus -2, so plus 2 plus -2 equals 0. So this side of the equation is now balanced. Okay, so the charge on that side is 0 now, the charge on that side is 0. Another way of writing this, which would be perfectly correct, would be to write your Mg there minus 2 electrons goes to Mg2+. A minus and a minus makes a plus, so -2 plus 2 electrons, minus and minus makes a plus, so my charge on that side is +2, my charge on that side is +2. Again, that is now balanced. Both of these equations are equally correct, and this one actually is quite helpful because it now tells us that magnesium loses 2 electrons. Okay, so the magnesium is oxidized because it's losing 2 electrons. So if we think back to the beginning, we said that magnesium gained oxygen, so therefore it was oxidized, but now we can say, right, okay, well, we understand this a little bit more. The magnesium loses 2 electrons, and that is oxidation. So the Mg is oxidized. Okay, now let's have a look at the oxygen. Okay, so what happened to the oxygen in that equation? I'll just write the equation out again here. So I've got Mg plus O2 goes to MgO. I need to balance that, 2 and a 2, like that. Okay, so my O2, my diatomic oxygen has become oxide ions. So my diatomic oxygen has become O2- ions. And how many have I got? 2 of them there, so I need 2 there. Okay, let's look at the charges then. The charge on that side is 0, and the charge on this side, 2 times -2, is -4. So 0 to -4. Okay, right, well, we need to balance those charges. If I've got -4 on this side, surely I can only balance things with electrons, because in chemistry electrons are the things that move around, that make things happen. Okay, so -4, I need to have -4 on the left hand side, and I can get that by adding electrons. So O2 minus 4 electrons, or plus 4 electrons, sorry, goes to 2O2-. Okay, so 2 times -2 is -4, and on this side I've got -4. That is now balanced. The oxygen has gained electrons, so O2 has gained electrons, therefore has been reduced. there we have it. So the O2 has gained electrons, therefore has been reduced. So in summary then, I'm going to write the equation out again, because we've got to be really good at this. Mg plus O2 goes to 2mgO, balance that up there. Okay, so what happened here? The Mg, this is 1/2 equation, the Mg became Mg2 plus, okay, plus 2 electrons. Okay, the O2 became O2 minus, 2 of those. Okay, so I need plus 4 electrons on that side. Okay, so the magnesium has lost 2 electrons to become the magnesium ion, and the oxygen diatomic molecules have gained 4 electrons to become 2 oxide ions. Okay, just for a bit of fun now, let's just put these 2 half equations together and let's just see what we get. Right, if the magnesium is losing 2 electrons, every time a magnesium becomes an Mg2+, it loses 2 electrons. Okay, how many of these do I need to balance the electrons on there? Well, I've got 2 electrons there, I've got 4 electrons there, so I think if I multiply all of that by 2, this might just work. Okay, so let's look at this. 2Mg plus O2 plus 4 electrons goes to 2Mg2 plus 2O2 minus plus 2 times 2 times 2, which is 4 electrons. Okay, that cancels. What am I left with? 2Mg plus O2 goes to 2Mg2 plus O2O2 minus. Okay, 2Mg 2 plus and 2O2 minus. So 2Mg plus O2 goes to 2MgO. There you go. Perfect. In part 2, we'll look at oxidation state and some more equations. Thank you for watching. Don't forget to like and subscribe and hit the bell notification to stay updated.